Okay, here today, let's go back to those discussions that we have had. This is your weekly participation evaluation since after your midterm examination to the last Monday. And some of you did participate well to solve the problems and revise or finalize. And the others who didn't do much get a 0 point on it. These will be counted as your weekly quiz point. So you're supposed to solve the problems or ask the questions and finalize the answer that you got from those discussions. And today we're going to cover the chapter 8 graph theory. And here we will study the paths and cycles and Hamilton cycles and traveling salesman's problems and shortest path algorithms and representation of graphs, isomorphism of graphs, and the Planner's graph. Okay, and I have given you the lecture note, and also I made the laboratory for chapter 8 in here, and also I gave you this graph theory homepage with the Python-based code that check your definitions and examples and the graph to count what we need. We will cover this. And also I have uploaded my lecture note with mark, and also I have uploaded a graph theory lecture note from Harvard University, and this is a lecture note at Harvard on graph theory, and these are they also covers the start from the paths and cycles and directed graph and paths and Eulerian work and Hamilton paths. And these are, so we will cover most of these contents, which is more detailed and in our lecture note. It also have some problems here that you may have interest. And also, I checked this and it was reflected in weekly evaluation. And we will have a final offline in-class examination in June. And and I asked you to solve the problems and revise and finalize in iCampus, so you can discuss the concept that we are learning and find an answer of the problem in the textbook. And I may so I asked you to finalize others' solution in the first 10 minutes of today's class, and you did so you did that. And also I may ask you to re-summarize the chapters that we have covered. Many of you made your summary of each chapter, but you still don't have a good summary of each chapters. So some may re-summarize with the others summary to make one good summary of each chapter. Then some other may finalize it, and then both of you may submit them in your May PBL report. Mr. Lee asked about, Mr. Wang Zhaoxiang asked about the gray code and Hamiltonian cycle that we're going to learn in the next week. And this GIF file shows an example of a Hamiltonian cycle that starts from one vertex, then passes through each of the vertices without repetition to come back to the starting point. Okay, and gray code is the one way to generate those paths. Okay, that we will study it in next week. So today we will cover the first two sections of chapter 8. Okay, and yeah, I have summarized the lectures and the references and lecture note and laboratories and movie clips of our lectures from first chapter to all the way to chapter 7, and we will continue to the last part of this class. And yes, and yeah, Krotowski's theorem. One of the students asked about the Krotowski's theorem, and this is an explanation of the history of this theorem and the related result. And after you read it, ask one more, then I will add more explanation on Krotowski's theorem. And my TA will make the evaluation of your quiz score each week based on your solutions and answers or questions. And Mr. Ju Kyung-yong, he asked how this code works, and what he misunderstood was when he added this equal line, that does not mean we define this as that. When you want to make it, then we should use the 2 of the equal sign. If you like this, if you define with the 2 equal signs like this, then this is gonna work. Like you see. Okay, here this is output, and let's see. So in the laboratory, if you put those command, oh here, not this. Okay, if you add commands, and press image. Let's see, what was the comment? Did I copy? Okay, we define that first, and then print the comments number. Then we will have Control V, and that we have it right. Okay, then we define the function first. It should work. It should work. Okay, we define a function first, then a common function with this, then we compute here. Okay. I will check it. I will check once again. What was mistype? And with this command, this is what I found. This is this is the output of those commands. So I checked it worked. And next, so the use a double equal sign to define functions. And Miss Lee added, so she summarized the chapter 8 with the graphs that we have had, and she she did fix it. Okay. The source of the resources that are using is important. It gives you credibility based on the authors and the web addresses and referees of the fact that you are using it. So it is important when you do note the source of your summary, but also you don't have to type all this again because you already have the contents as a lecture note and the PDF files that I gave you, and on the also web resources that I made you. So you can just copy those and you can add your comment on those to summarize it. That's the way that you learn how to write a scientific report. If you do not refer the source, it can be considered as a plagiarism. 그러니까 표절이 되는 거예요. 그러니까 인용하지 않으면 남의 자료를 쓸 때 인용하지 않으면 표절이 되는 거고, 그보다 더 중요한 게 여러분들이 아무 데서나 가져온 게 이게 사실인지 아닌지를 모르기 때문에 그걸 다 확인을 해야 되는데 누구도 그걸 확인해 주지 않아. 그래서 그 믿을 만한 소스에서 가져온 것들, 어디서 레퍼리가 검토해서 페이퍼로 나온 자료들, 이제 그것들만 인정해주고 나머지는 거의 읽지 않으니까, 그러니까 꼭 믿을 만한 소스를 활용하는 걸 배워야 돼요. You have to learn those while you are in the school. And sometimes I added some reading materials, and I expect this is a part of this learning experience in our class. So I expect you can add your comment or your thought on these, because I think this is telling you what kind of abilities that you have to learn for your future career. And this is what we are learning in this class. Yeah, I also continuously ask you to finalize other solution and discussions and summaries. And I think some of you who expect a good grade from this class, yes, should do. You have to learn how to talk about the knowledge that you are learning from this class with the others. So at the end, you should be able to explain what you have learned to others. Okay? You have to talk. You have to start to talk. Yeah, I also asked you to take a look on those definitions that we're going to learn in the next 2 weeks. And this website has not only the explanation, but also it has all the Python-based code for the introductory graph theory. Actually, as you saw here, actually, this graph theory and combinatorics is a 1 semester course at Harvard, but now you are learning the basic introductory knowledge on graph theory in 2 weeks in this discrete mathematics. So it has a lot many informations in here, but you don't have to learn everything, but you just take a look and be familiar with some terminologies that you're going to see and meet over and over again. That's our intention. And Mr. Ju Kyung-yong added the code for those problems, so they can copy those code to practice in these pages. And okay, I think that's enough. Yeah. Yeah. Okay. Yeah, you did. Okay. Hanoi's Tower. Okay. Here, who asked? 이거 누가 물어봤어요? Who asked about? Okay, this is, and also I think there was one interesting question here. Here, Mr. Kim Dong-jun. Do you understand now? On the answers that I gave you, you asked on Hanoi's Tower if we have more than 3 bars when you move one stack of disks to the others. And this is my explanation. Answer is yes. The equation will be changed. Recurrence relation will be changed when you have more bars, more. Because think about it. If we have 64 disks of tower, okay, and suppose we have 65 bars, then what we can do is move each one of them in the other bar, okay? Then every 64 disks listed in each of those bars, okay? Then then we take 64 and 65, we made 65 moves, okay? Then all you have to do is move the second largest one on the top of the largest one. Then third largest one on the top of the second largest disk, and next, and next. Then all you have to do is move 64, 65, and then 64. So after 129 seconds, the movement from one tower to the other will be done. So we will have a totally different recurrence relations. Okay? So when you have more bars, then definitely you will have a difference relation, recurrence relation. Understand? It was a good question. And who was the? This was also interesting. Interesting question. Yeah, why we using these characteristic equations? Who gave this? Who made these questions? Who was it? Characteristic equations. Okay. So solution. Solution. This equation, this characteristic equation can be written in this way. So solution for this is t is equal to 0 with a multiple root, and we have a quadratic equation of degree 2 here. So solution of these two are the ones that we really need. That's why characteristic equation, we don't care about this part. We only concentrate on this quadratic equation for a recurrence relation with two terms like this. Okay? This is the reason. Okay. And yeah, there was many discussion on Ackermann's functions that we learned in chapter 7. And what was also a companion matrix. Here, this is also, what was the questions? Linear homogeneous recurrence relations and linear homogeneous and linear homogeneous. 수학에서 선영대 수학에서. Anyway, let's think about this these recurrence relations, and this recurrence relation can be translated in a polynomial like this, and then this polynomial, if we define a matrix like this, then we multiply here a vector. Then what we're gonna see is after you multiply this matrix, then what you're gonna see is the next term. It will be moved because the very last one is the one that you're gonna add when you multiply a vector here, then at very last one you will have the second term. The others are just the shift of it. So the solving this problem is like solving this problem. So handling this polynomial is the handling this kind of recurrence relations that you have with this corresponding matrix, which is called the companion matrix. Okay. When you multiply a vector here, then this and this gives the next term. Next term, like this. So this recurrence relations can be translated this kind of the matrix power problems, the recurrence relation and the linear system of equations in linear algebra is basically the same problem. That's why you learn the linear algebra to effectively handling this type of polynomial and also the recurrence relations. It's all related. That is called that companion matrix give a bridge on those. Okay, I think that will do it. Oh, actually, one more. What was the one more interesting thing? Here. One more interesting things. series recurrence what was title? Online dictionary or integer or in online library of integer sequence or this. Online encyclopedia. This will be also interesting. Okay, here. Yeah. Yeah, Mr. Kim Dong-jun. And this was, yeah, you made many interesting questions. Here, yeah, your comment was right. And after, yeah, you find the recurrence relations, then, yeah, we need to verify the equation that you found, the solution that you found is the right one for the given recurrence relations. So in that case, yeah, we need a mass induction to check it. But also, if you have a general term for AN, then you can generate easily all the list of the integers, isn't it? Then you can compare those with the given sequence of integers. You can easily check all the given ones to be checked. If everything's are matching, then it's done. So there are several ways, the other ways. This is an interesting site. This is called the Online Encyclopedia of Integer Sequences. So the same question was made by other mathematicians. So whenever you have a series of sequences, they made the encyclopedia. So if you have the sequence of a series of sequence of integers, then you can by giving those numbers in here and to search it, it gives you all the results that is related with it. These numbers can be found in here, and this has a history, and this sequence has been examined. It has solutions, and all can be found in these papers. Like here, here that can be a solution for these equations, and the code and those series can be found with this code, and that's the kind of recurrence relations and all those. For example, if you have what 1, 2, for example 4, 6, 8, for example, then we'll see. Then the answer for this sequence, you can find this can be a part of this, or this number of integers are part of other series. It can be a part of this form of sequence, or this is part of others, and there are many possibilities of those numbers. And these are all the researches which has been done here. So and also, yeah, that value can be found in these sequences. That value can be increasing gaps between primes, and like this. So for at least many people has interest on the sequence of integers. So here, let's say a Fibonacci number here. So let's check it. The number 1, 1, 1, 1, 2, and 3, and 5, and 8, and 13, for example. Yeah, let's think about what are the. This sequence is a Fibonacci number. This can be a first part of Fibonacci number, which has this recurrence relations, and those research has been done in here. And these are the list of Fibonacci numbers, first 10, 20, and also that those numbers can be, and those research has been done in these many articles, and there are formulas here, and there are code for that, and there are many information. Also, those numbers can be a triangular array. First part of triangular array, T read by rows of this, and this research has been done in here, something like that. Also, that numbers can the first difference of these numbers, and that could be a first part of this number series sequence, and that's like this. So, if you have any sequence of numbers, then you can easily check whether it's been studied by others before. So you don't have to waste your time on those research which was done by others before. So, but if you don't find anything from here, then that you may try to find an answer from that. Okay. Okay, now I think you are ready to start. Mr. 유승재. Okay. Yeah, what we going to learn today? Okay, yeah, we're going to learn about half of the chapter 8 today, and we will finish up the another half in the next week. Okay, yeah, this could be covered in the next week. And Nabil, yeah, what are we going to learn today? Nabil, where is yours? Mr. 박종호. Okay. Mr. 홍석호. Yeah. What are we going to learn today? 엣지와 버티시스들로 이루어진 그런 오브젝트를 그래프라고 하고, 그 그래프에 관련된 예들을 보고 성질들을 보고 그렇겠죠. Okay. Okay, I think you are ready for chapter 8, so we will start.